And is my PDF visible to you guys? Yes or no?
Yes, sir.
Okay. So today we are going to do experiment number 3, and in this experiment we will be talking about, or we will be learning about the heat engine and the refrigerator. These There are two kinds of thermodynamic system. Although there is another thermodynamic system which is called heat pump as well. We will be learning this in experiment 4, but today we will learn about these two uh, work producing devices. This is a work producing device, and this is a thermodynamic system. And we'll see what exactly these heat engines and refrigerators does. We'll talk about theories behind it, and we will first talk about theory, and then we will take up things. We have case 1 and case 2 based on. So the case 1 is based on heat engine, and case 2 is based on refrigeration cycle. So, and both these cases we will take up in the EES software. Although this software is kind of outdated, um, but since this is a part of our curriculum, so we will learn some software to analyze or to calculate uh, some sort of algebras, and we can do some plottings as well. Although I would uh, recommend you should use this software instead, MATLAB, or there is an alternative called Scilab, and there is one more alternative called Octave Online. So these two softwares, Scilab and Octave Online, are free to use, but MATLAB you need to. This is a proprietary software. You need to buy it. Anyways, today we will be taking up things in ES software, which I believe that most of you have installed it, and I will do this particular case 1, about the heat engine, and this next case you should be able to do it at your own as an assignment or as a um, next task for this experiment number 3. Uh, so let's start with the theory of uh, these thermodynamic systems. Uh, Let me first talk about what these all about. So in order to do that, let me switch to my OneNote. So is my OneNote visible to you? This page is visible?
Yes, sir.
Yes, no? Hello?
Yes, sir.
Okay, thank you. So let me take another page. The aim of this experiment is to evaluate the thermodynamic system, uh, which is nothing but your heat engine or your refrigerator, by the means of EES software. Okay. So first of all, I just wanted to tell what do you mean by evaluate the thermodynamic system is to we are referring in order to evaluate its performance, or in terms of efficiency, so to say. We are more interested in efficiency of these two uh, devices. So let me first tell you about the theory of this heat engine. So the basic definition of heat engine is it's kind of device. It's a device that converts heat energy to mechanical or some sort of work, some advantageous work we can get out of heat energy. And this device essentially converts the heat energy to mechanical work or mechanical energy. Okay. The first thing we need to understand is so so this course is all about, so this heat engine itself, if you want to learn this about this heat engine itself, it is a whole course on it. So this particular EME lab is not sufficient to tell everything about it, but let me just briefly tell you what this heat engine is all about. So in your automobile or in your car, um, in front of you there is a cabinet, and in this cabinet your internal combustion engine is kept, and this internal combustion engine is essentially a heat engine. Okay. And due to this internal combustion engine, we with, let's suppose we have a petrol tank over here, and we are going to burn the petrol or your diesel, and due to the combustion the heat energy produces, and with this heat energy, with this heat input, that when while burning the petrol, we uh, cleverly we design our heat engine in such a way that we have a piston, we have a some sort of arrangement, some sort of kinetic arrangement, and because of this certain arrangements, we take fuel and air, we combust it, and we try to push this piston downward, and with this downward movement of piston, this crank is going to rotate, and this crank is essentially connected to your wheels, and the wheels are going to rotate in certain direction, and you move forward because of the friction between your wheel and the road. So that is how your IC engine essentially works. This particular part is, this particular arrangement is internal combustion engine. This is called internal combustion engine. I'll go very basics. I mean, this is not a course about you to tell everything. Uh, so, I mean, just I'll give you overview what heat engine is all about and what this refrigerator is all about, and then we will move into solving things in ES. But let me just give you a brief introduction about it. So this is an internal combustion engine which takes up some sort of heat. So in a way, let's suppose this is your control volume. In some sense, you are inputting some heat energy, and out of it you are getting some work, isn't it? So this is the main, let's suppose this is my black box, and this black box is called internal combustion engine, or in short, in generic sense, it is called heat engine. So this heat engine essentially takes up some heat energy, and in turn it produces some work, and that is what is our main goal is. But let's suppose, let me ask someone, if is it possible, when if I'm inputting my 100 uh, kilojoules of energy, if I'm burning through petrol, will I get 100 kilojoules of work? Can I get?
No.
Anybody? What could be the reason? Thank you. It's a correct answer, but what could be the reason? I mean, why you cannot get 100 kilojoules of work? I mean, um, what is the fault in this engine? So when we calculate the efficiency, so work output is your 100 and your heat input is your, that is 100, and you can see the efficiency percentage is 100%, and which is not acceptable, or in this we may not find, we will not find any device which works 100% efficiency. So uh, that is a statement made by Clausius and Planck, sorry, Kelvin and Planck, I'm really sorry, Kelvin and Planck, Kelvin and Planck, he made a statement about certain device that uh, it is impossible, it is impossible to construct a device, to construct a device in cyclic fashion. So this cyclic word I should not tell you right now, because this is a way around, I mean very complex things will come. Just keep in mind that it is impossible to construct a device which works in cycle and produces all the work from heat. Okay, it will not happen. So there is a catch. So this catch is, so your device must release, so this is a catch, your device must release some Q out in order to function it properly, or in order to function it uh, in a best ethical way, not ethical way, I could say best universal way. Okay, so in this particular universe, you should have some Q input and then you will have some output, but in turn, you should also have some Q out. It may be less or more depending upon the efficiency of the engine, how efficient it is, but this is the basic structure of any heat engine. Okay. Now, let me tell you what could be the efficiency of the engine is. Now, this particular engine which I have devised, this particular engine which I have devised, that this is a heat engine and it is taking some Q in, it is giving some work out, and it is also giving some heat to environment as Q out. Okay, so the efficiency can now be calculated. This for this real device, you can say, not optimal device, real device is W out divided by Q in. Okay, so this is how we generally calculate our efficiencies. So how much efficient you are? So so I am giving I am studying 5 hours a day, but uh, I can study 10 hours, so my efficiency is half. That is how you calculate efficiency, isn't it? So this is how you can calculate the efficiency of a typical heat engine as well. Okay, heat engine, or your internal combustion engine, or your car engine, you can say. So this workout, I can write this workout if I talk in sense of, let's suppose this is my control volume. So the energy coming in and energy coming out and out. So energy coming in is must be equal to all the energies that are going out, isn't it? So that is how my first law of thermodynamics is all about. So energy is neither created nor destroyed. So Q in, so from here, so from first law I can write Q in must be equal to work out plus Q out. So this work out I can write here as Q in minus Q out, right? Q in minus, I'm sorry, Q in minus Q out. So I can substitute it here, and then I can write a proper expression, Q in minus Q out divided by Q in. So I can take I can do the division, and I can write a proper expression, 1 minus Q out divided by Q in. This is your efficiency of any engine, I can write. This is the formula. uh, I can I should have used it, but in this particular example, things are slightly different. Okay, don't take it as uh, so. This is kind of I'll not tell that this is a complex thing, but yes, there is another concept that uh, overcomes here is something called Carnot engine. So that is why I don't like this particular lab or this particular course, because you guys are from different backgrounds and I need to tell you everything in one I don't know one in one class, and that is not possible. But anyways, I'll try to get things done. Okay, so far so good. So we have efficiency. So we have efficiency 1 minus q, what was that, q out by q in, right? Yes. Oh, right. Fine. Okay, one more concept I want to tell you quickly. There is something called Carnot cycle. uh, I don't want to tell in details, but there is a guy called Carnot. He came up with certain idea. He told that whenever your heat engine is running, okay, and it is taking some Q in, and it is giving some work out, and it is also liberating some heat Q out in the environment. So he told that the maximum, the maximum efficiency, this heat, this particular in any uh, uh, hypothesis, sorry, the hypothetical, I'm really sorry, hypothetical engine, this hypothetical engine with maximum work, it would work only if it will depend upon this, the efficiency would depend upon the temperatures that it is having. So T in, the source temperature it is having, so it is taking temperature from some furnace and it is giving heat to some environment. So environment temperature is, let's suppose, 27 degrees C, and the furnace temperature is, let's suppose, 500 degrees C. Okay, so what he told that he devised that, I'm not going to take up this as, so just take it as a granted that Carnot told that the maximum efficiency of this engine would be 1 minus T lower divided by T higher. So this is T lower, this is T higher, furnace, and this is lower environment. So this is what TH and TL, and this would be its maximum efficiency of any engine, and this engine was called Carnot engine. Okay, now let me club these two concepts together, because in our case one, a bit, this is a bit tricky, because they are asking maximum workout, they are asking for maximum workout. So let me read the question first. So we have a higher temperature reservoir, okay, or a furnace at TH temperature, and it is taking up some QH heat. This heat engine is taking up some heat which works in cycle. Okay, we will not talk about what cycle it is, but there are some cycles that is working. It is giving some work out, and it is liberating some heat QL at lower temperature reservoir, which is your environment or your river or your atmosphere. The reservoir is at 550 degrees C, and it is taking heat. This is Q in, it is taking, rather this is a Q dot in. Why? Because this is kilojoules per minute. So this is a Q dot, dq by dt is given. So it doesn't matter, it's all same. So, and the temperature of the environment is given 25 degrees C. So how much work max it can get out? This is what our question is. If you read it properly, the heat engine operates between source and sink. This is called source. This is also called source, and this is called sink. And if the heat is supplied to the heat engine at steady rate, this much heat is supplied, determine the maximum power output of this heat engine. Okay. And then there are several. There is a variant of this question that source temperature may vary from here to here, and then plot uh, the performance or efficiency versus TL or TH or something. Okay, so don't worry. First, let me go through how you are going to calculate the maximum work out of it. So the maximum work you should calculate in this fashion. So maximum workout can be taken up from this particular guy, the Carnot engine. So eta max can be written as 1 minus TL lower temperature or the sink temperature or TH. This can be written, and this N max can also be written as W work out max divided by Q in, isn't it? So from this formula, I can actually estimate my work out max. And this max is, we are calculating this max in the assumption that it was running with Carnot. Carnotically it is going, or it is working in a Carnot cycle, simply, so to say. That is why this Q out and Q in is being replaced by TL by TH, and this is called thermodynamic relation or something. So we don't have to worry much. Just in the concept, you should just replace this Q out by Q in by TL by TH, and this is what Carnot told, that when you replace this TL by TH in kelvins, you will get the maximum output of the engine. So so don't confuse it. These two things are similar, but in a way, it the right hand thing gives me the maximum thing, and that is what we are intending to find. Otherwise, if you could have asked what is the usual output it is giving, then just you can take work by Q in, and you can write 1 minus Q out by Q in, and you can actually estimate your work. But here, since maximum is asked, so we have to use Carnot efficiency cycle. And this is a hypothetical cycle which works hypothetically, but it gives the maximum output of it. And this workout max can be written in the, you can multiply it here, Q in times 1 minus TL by TH. Okay. And one more thing, here we can actually differentiate with respect to time, and we can get W dot. So this is work out, rate of workout, maximum rate of workout. So this is maximum rate of workout is written as Q dot in, which is provided 1 minus TL by TH, which is also provided. TL is equal to how much? How much temperature we have? 25 degrees C. So we can write Q in is our 1200 kilowatts, 1200 kilojoules per minute. So 1200 kilojoule per minute. Okay, times 1 minus TL is 25 degrees C, and this T hot is 550 degrees C, but we need to convert it into Kelvin. So we are going to write 25 plus 273 in order to convert in kelvins, divided by 550 plus 273 kelvins, and that's it. You will get the W dot max from this expression. So anybody has calculator? So one thing I want to I also want to tell you that we can convert this minute to seconds, and we can write kilojoule per second, and this is your watt, kilowatt, and 1 minus how much, this much, 5 3 8, I don't know, 298 divided by how much, this 3 7 5 12 8, if I'm not wrong. Okay. So can somebody calculate it quickly? What is my work max? Please calculate and tell me the answer. Anybody?
12.75 kilowatt.
Thank you. Thank you. Thank you. Who is this? Who is this? 12.7. Very, very nice. So 12.7 kilojoules per second is my work output. Thank you very much. Thank you. You are correct. So now let me. So this was the theory part. Now let me take up this thing into EES software. Now I would suggest everyone to uh, open your EES software, which I've already shared with you in our WhatsApp group. So this is the EES shortcut we have. Let me open that. Now let me do the continue. Okay, now you will have this interface. Okay, these have file, edit, search, options, calculate, tables, plot, and everything. And this is your equation window. We are going to write some equations, and then we will try to uh, evaluate this expression what we got. Okay, so let me do it quickly for you guys. So let me write the expression. So you can also side by side, you can also do it parallelly with me. T underscore H, T hot, is equal to 550, and that too space, that too in degree. Yes, in degree C. This is in degree C. Okay, enter T underscore capital L. Although I do not like this software because this is outdated, kind of outdated. I mean, people are using MATLAB these days, MATLAB, Scilab, but yes, since this is in curriculum, so uh, we need to learn this. 25 degrees C is my lower or source sink temperature. This is in degree C. Put enter, and then Q supplied, Q underscore supplied is equal to or Q dot supplied. Let me write this way: Q underscore dot supplied underscore supplied. We just calculated. It is 1200 divided by 1200. This kilojoules per minute था, इसको हम convert करेंगे kilojoules per second में. And then I will write that this is kilojoule per second, and fine, enter. Let me hit enter, and then we have efficiency, that is eta, thermal efficiency this is called, but I'll write only eta. Eta is equal to what is my formula? 1 minus bracket T underscore L plus 273 degree C, sorry, plus 273, that is my Kelvin. Okay, and divided by bracket t underscore hot plus 273. Again, we need to convert it into Kelvin, and yes, and then W, capital W underscore dot underscore out. I will write. I'm defining just variables. Okay. This you can also do it in calculator, but since we need to learn this software, so this outdated software, I don't know why we are using this, but let's do this. Okay, this is Q underscore dot underscore supplied applied times eta, right? That's it. So our equation window is ready. Let me save this. Okay, let me save this with some name, maybe uh, computer science 2020, and this would be saved in .es file in my documents. Okay, now next thing is to uh, there is a check window here, check equation. So let me check this equation. So there are 5 equations and 5 variables. No syntax errors were detected. Compilation time 0 seconds. So my equation is perfect, and we can ready to go. We can ready to calculate. So now this is a calculator button. You just have to click solve. When I hover here, tells solve. So just clicking here, I get the efficiency and my W out. So this is what W out we get. W out is 12.76. One girl told that 12.7, and yes, this is correct from our ES software as well. Okay. Now the next thing I am going to tell to how to make this particular observation table. Okay, and we will try to plot some uh, W out with some temperature TH or TL. We can see some trends. We'll see how we can plot it. So for this observation table, what modification we have to do is, uh, you can see in this particular observation table, this TH is a variable. So there are certain variable. I mean, this TH is going to vary, or it's kind of vector. Right now, this TH here is treated as a scalar. Okay, 25 degrees C or 550 degrees C. But this we need to take up this as a vector. Okay, how to make the vector out of it? So in order to make it vector, we have to put curly braces in the beginning and at the end as well. Here also, we are going to vary our pH, and we need to see the trends. That is what we are asked to do. Okay, and we are going to save it. And when you try to check the equation, it is saying that there are 3 equations and 5 variables. Why? Because I have made this as a vector. Okay, that's fine. So now what I will do is I am going to make a table. Okay, so you have to make a new parametric table. Okay, total number of runs is 8, table number 1. And what are the things variables I want? Eta add, q dot add, ph add, tl add, w dot out also I want. Okay. And okay, hit OK. So you will have this sort of table, observation table is ready. Now you have to fill this, fill what? Fill TH. Okay, from 300 to 1000. So TH, click here. When you click on TH on third column, okay, you will get first row and last row. First value is 300. We need to vary TH from 300 to 1000. Okay, hit OK. Okay, so now it has been tabulated. See, okay. Similarly, TL also first value is 0 and the last value is 0. Okay, this is all 0. Okay, now hit run from here, this green button, and let's see what happens. So this, all the things have been tabulated. Okay, all the efficiencies, all the corresponding efficiencies has been tabulated. W outs has been tabulated. So see, at 500 temperature, when the source temperature is 500 and the sink temperature is 0, it is almost equal to 12. So that is why we can say that this is a true table. I mean, this is a good table. This is a right table rather. So now your table has been ready. Now we are going to plot xy. Okay. I want to plot uh, w dot out in x-axis. So x-axis w dot out, y-axis, sorry, y-axis I will take w dot out and x-axis th, and let's hit run and let's see what happens. See, in x-axis you have th 300, 400, 500. When I am going to vary up my blast furnace or the petrol combustion temperature, it is going to vary. My w dot out, what is the maximum output I will get, or what is the maximum uh, uh, output to run the wheels, is the trend is something like this, and this is what it was asked to do in this particular cases. So there are two observation tables, so not two. Okay, so what you have to do is, next your task is to, so this your th is similar. Now TL you can vary 25 degrees C, 25, 25, 25, and you can tabulate all these thermal efficiencies, and now you can plot your W out and TH. Also you can plot on top of it efficiency versus TH. All sorts of plotting you can do. Third observation table is TL also you can vary with 50 degrees C, and you can tabulate all these tables. Okay, you can do this. Okay, yes or no? कर पाएंगे?
Yes, sir, but when we are
Yes, sir.
opening the ES software, it is showing that
हाँ,
um,
एरर दिखा रहा है.
this demonstration version has expired. Download a new version from info@fcharge.com, something like
उसमें बताता हूँ मैं. इसमें आप क्या करेंगे, इसमें एक रीडमी फाइल है इंस्टॉल. उसमें क्या करना है, es.dft जो है, ये वाला जो फाइल है पहला वाला, वो उसको कॉपी करके पेस्ट कर देना है आपको जहां ये इंस्टॉल हुआ है, समझे? आपको ये फाइल, ये वाला फाइल जो है, ये रीडमी फाइल खोलेंगे, पहले इंस्टॉल करना है. इंस्टॉल आपने कर लिया होगा, अभी नहीं चलेगा. Copy ESDFT file to the ES directory where you have installed the software, and then enjoy. So this you should copy and go to your C drive. Although I should not tell you, because this is a proprietary software, I should not tell you online. I may get trouble. So this is EES32 is installed over here. You just go to this folder and just replace it, paste. When you paste it, you will be ready to go, and then you can run this application over here. Okay, try doing it right now and let's see if it works or not. Quickly go through it. So I would request some of the other guys also to do this. दीप पटेल, आप हैं यहाँ पे? दीप पटेल नहीं है. फेनिल.
Excuse me, sir.
हाँ.
Sir, can you repeat part of with the parametric table?
हाँ हाँ, बोलिए.
Sir, can you repeat about the table part? How we have
टेबल पार्ट हम कर देते हैं. Okay. 1 second. सो टेबल पार्ट के लिए आपको क्या करना है, ES सॉफ्टवेयर में कहाँ से आपको समझ में नहीं आया था? न्यू
सर वो
टेबल
वैल्यूज पुट करने के बाद सब।
वैल्यूज पुट करने के बाद, 1 सेकेंड, इसको क्लोज करते हैं अभी। यहाँ तक आप लोग लिख लेंगे, ठीक है। उसके बाद टेबल्स पे क्लिक करेंगे। अभी कैलकुलेट करना नहीं है क्योंकि इक्वेशन ज़्यादा है मेरा, मतलब नंबर ऑफ वेरिएबल्स, तो कैलकुलेट होगा नहीं, बट टेबल्स बन सकता है। न्यू पैरामेट्रिक टेबल करेंगे, ठीक है। नंबर ऑफ रन्स मेरा 8 रहेगा, ठीक है। जो जो वेरिएबल्स आपको चाहिए सब उधर डाल दीजिए। मे बी आप कुछ वेरिएबल्स नहीं भी चाहते होंगे, बट हम सारे वेरिएबल चाह रहे हैं। ओके कर देते हैं, मेरा पैरामेट्रिक टेबल तैयार हो गया, ठीक है। अभी हमारा क्या है, TH पॉपुलेट करना है, तो TH पे क्लिक करेंगे। फर्स्ट वैल्यू मेरा 300 है, दूसरा वैल्यू मेरा क्या है, सॉरी लास्ट वैल्यू मेरा है 1000, ठीक है। बस इसको पॉपुलेट कर देते हैं, तो ये पॉपुलेट हो गया। सिमिलरली TL मेरा है 0 है, पहले केस के लिए सभी 0 है, तो इस यहाँ पे क्लिक करना है हमें। बेसिकली यहाँ जो ये जो डाउन साइन है ना, वहाँ पे क्लिक करना है। फर्स्ट वैल्यू मेरा 0, लास्ट वैल्यू भी 0 है। ओके कर देंगे। नाउ हिट दिस ग्रीन बटन, इट विल बी पॉपुलेटेड, everything will be populated, and then you can go for the plotting. New plot, XY plot, and क्या क्या प्लॉट करना है वो देख लीजिए आप अपने हिसाब से। जो क्वेश्चन में दिया हुआ है आप देख लीजिएगा। क्वेश्चन में एक्स एक्सिस में प्रोबेबली TH है और वाई एक्सिस में W डॉट है, एंड हिट ओके। तो दिस इज योर प्लॉट,
थैंक यू सर।
ठीक है। आप लोग नहीं, बात है सॉफ्टवेयर इंस्टॉल कर लीजिए, नहीं तो फिर आप नहीं कर पाएंगे। अभी मेरे सामने कर लीजिए। दूसरा वाला जो है वो भी हम क्विकली हम बता देते हैं। एक काम करते हैं, दूसरा वाला जो रेफ्रिजरेशन साइकिल है ये भी हम बता देते हैं आपको, ठीक है। इसके बारे में भी हम थ्योरी थोड़ा दे देते हैं। तो यहाँ पे ही थ्योरी क्विकली दे देते हैं, ज़्यादा कुछ बताना नहीं है इसमें। अब मेरा एक और डिवाइस है, जैसे कि लोगों ने हीट इंजन बना लिया, जैसे कार ड्राइव करना शुरू कर दिया, IC इंजन बना लिया, बहुत खुश हो गए, बहुत बढ़िया काम कर रहे हैं, हम हीट इंजन ले रहे हैं और कुछ क्रैंकशाफ्ट घुमा रहे हैं और हम व्हील घुमा दे रहे हैं। वाओ, दिस वाज एक्चुअली रिवॉल्यूशनरी आइडिया हीट इंजन का। कुछ लोगों ने ऐसा सोचा कि हम लोग कुछ और भी काम कर सकते, कुछ उल्टा काम करते हैं यहाँ पर। तो कुछ लोगों के पास कुछ आइडिया था, उन्होंने बोला कि हम एक रेफ्रिजरेशन साइकिल करेंगे, ठीक है। रेफ्रिजरेशन साइकिल करेंगे और उसमें क्या करेंगे कि मेरा एक ये रेफ्रिजरेटर होता, लेट्स सपोज दिस इज माय रेफ्रिजरेटर डोर, let's suppose this is my refrigerator, and this let's suppose this is my refrigerator, and this is a cooling space where I want cooling, so this is the cold refrigerated space. उसने क्या किया, उसने एक इस रिसर्चर ने प्रोबेबली, इफ आई एम नॉट रॉन्ग, क्लॉसियस और प्लैंक वगैरह ने मिलके किया। इंग्लिश प्रोबेबली यूरोपियन ये लोग रिसर्चर थे उस टाइम के, प्रोबेबली 1900 और 18 समथिंग में। उन लोगों ने क्या किया कि उन लोगों ने एक कंप्रेसर रखा, यहाँ पे एक कंडेंसर, फिर एक्सपेंशन वॉल, एंड देन इवेपोरेटर, एंड द वर्किंग फ्लूइड हियर इज योर सम रेफ्रिजरेंट, सम रेफ्रिजरेंट ही टुक, एंड रेफ्रिजरेंट का कुछ सर्टेन प्रॉपर्टीज़ था। वो प्रॉपर्टीज़ के कारण वो जब साइकिल में ऑपरेट होता है तो वो क्या करता है, यहाँ से जो इवेपोरेटर होता है वो जिस स्पेस को आपको कूल करना है वहाँ से हीट निकाल लेता है। दैट इज़ द कैच हियर। यहाँ पे क्या होता था, हीट इंजन में आप हीट इनपुट करते हैं और आपका IC इंजन रन करता है, वर्क देता है, और कुछ आप हीट जो है बाहर की तरफ छोड़ देते हैं इन ऑर्डर टू मेक श्योर दैट फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स वायलेट नहीं हो। यहाँ पे ये क्या करता है, ये रेफ्रिजरेटर ऐसे वर्क करता है, इसके डिटेल में नहीं जाएंगे अभी क्योंकि ये भी पूरा एक कोर्स होता है मैकेनिकल इंजीनियरिंग में। पर वो क्या करता है, सरप्राइजिंगली वो हीट जो है वो लेता है इन और वर्क इस पर करना पड़ता है हमें, ठीक है। वर्क इन करना पड़ता है। वर्क इन जब हम करते हैं, कंप्रेसर चलाते हैं, जो आपका ये चीज़ आपका AC भी हो सकता है, ठीक है। AC आपका एयर कंडीशनिंग यूनिट आपके घर में आप अच्छे से भी बैठे हुए हैं ठंडे स्पेस में। आपका एसी भी ये बोल सकते हैं, रेफ्रिजरेटर भी बोल सकते हैं। इसमें कंप्रेसर जब चलता है तो जो मेरा डिजायर्ड स्पेस है उससे हीट ले लेता है और बाहर की तरफ इन्वायरमेंट में हीट को लिबरेट कर देता है। सी कितना रिवॉल्यूशनरी आइडिया था ये, लेकिन जिसका ऑपोजिट था, हीट इंजन का ऑपोजिट था, बट ये भी एक अच्छा आइडिया था। तो यहाँ पे मेरा, जब हम इफिशियंसी की बात करें, हाँ यहाँ पे इफिशियंसी की बात हम लोग नहीं करते हैं। यहाँ पे एक दूसरा पैरामीटर होता है जो इसके परफॉर्मेंस को जज करता है, उसको बोला जाता है COP, कोफिशिएंट ऑफ परफॉर्मेंस। परफॉर्मेंस जो COP होता है वो भी सिमिलर होता है, काइंड ऑफ एनालॉगस टू एफिशिएंसी, बट COP इज डिफाइंड एज योर, दिस इज योर डिजायर्ड आउटपुट, दिस इज व्हाट यू वांट। एक्चुअली यहाँ पे हम क्या चाहते थे, मेरा डिजायर्ड आउटपुट ये है, ठीक है, वर्कआउट मेरा डिजायर्ड आउटपुट है, पर यहाँ पे हम चाहेंगे कि ज़्यादा से ज़्यादा मेरा हीट जो है कूल स्पेस से निकाले, मतलब जो नॉर्मल स्पेस है जहाँ हम रहेंगे, यहाँ पे हम रहेंगे, घर है मेरा, तो यहाँ से मेरा ज़्यादा से ज़्यादा मेरा हीट निकाले। इसके लिए ये मेरा डिजायर्ड हुआ, तो QL डिवाइडेड बाई वर्क इन, यहाँ पे उल्टा होता है, ठीक है, एंड दिस इज योर कोफिशिएंट ऑफ परफॉर्मेंस ऑफ योर रेफ्रिजरेटर, दैट्स इट। ओके, तो इसमें भी सेम एक क्वेश्चन दिया हुआ है, ये क्वेश्चन आप लोग खुद से करेंगे और इसको ES में डाल के सेम पॉपुलेट करेंगे और पावर निकालेंगे, जो भी दिया हुआ है ये ट्राई करेंगे आप लोग, ठीक है, ES में। तो इसका हम डेमो नहीं देने जा रहे हैं, इसमें ज़्यादा कुछ है नहीं, जितना हो सकता है उतना कीजिएगा। आई विल बी lenient enough because I know that you guys are from several background, you won't be understanding much, but मेरा ऐसा मानना है कि आप एटलीस्ट कॉन्सेप्ट वाइज समझ जाएं कि रेफ्रिजरेटर मेरा कैसे काम करता है और मेरा जो हीट इंजन है या IC इंजन है मेरे कार का या मेरे बाइक का, वो कैसे काम कर रहा था, ये एटलीस्ट हम जान पाए। मेरा ये मोटो है, इतना समझ जाए आप कम से कम। तो हाँ, रेफ्रिजरेटर में मेरा डिज़ायर्ड मेरा ये था आउटपुट, मेरा QL कितना निकल रहा है और WIN हम कितना कंप्रेसर को चलाए, वो COP होता है, और COP 1 से ज़्यादा हो सकता है, इट्स फाइन। एंड बेस्ड ऑन दिस फॉर्मूला ओनली यू नीड टू रन दिस केस, ठीक है, ट्राई टू डू दिस, ठीक है, कर पाए तो ठीक है, नहीं कर पाए तो भी ठीक है, एटलीस्ट आप लोग समझ रहे हैं नहीं वो मुझे बताइएगा। और ये वाला केस भी आप लोग ऑब्जर्वेशन 2 और ऑब्जर्वेशन टेबल 3 आप लोग कर पाएँ या नहीं बताइएगा। अभी आप लोग बताइए अब मुझे कि ES में किन किन लोगों को प्रॉब्लम है अब
Sir,
इंस्टॉल
I
हुआ है?
can
हाँ,
find that folder ES32.
आपने इंस्टॉल कर लिया?
Should I reinstall?
नहीं नहीं, आपने इंस्टॉल कर लिया या नहीं?
The day you gave the link, we did that day.
हाँ हाँ, आपने किया ये, हाँ आपको इंस्टॉल करना है, अभी कीजिए अभी आप लोग, फिर नहीं हो पाएगा, 10 मिनट में कीजिए। तो व्हाट्सएप पे मैंने लिंक भेजा था, उससे वापस कीजिए।
Okay, sir.
सभी लोग कीजिए, ध्रुव पटेल, हर्ष, कुश, कुंज, मीत, नेह, ये कौन है, OMG, ओम, सॉरी ओम है, सभी लोग करें अभी, मेरे सामने करें 10 मिनट में, ठीक है। आई वॉन्ट एवरीबडी टू डू दिस इन फ्रंट ऑफ मी। अभी कुछ दिक्कत होता है तो अभी पूछ लीजिए, उसको फिर हम बता देते हैं। यश प्लीज रिस्पॉन्ड, स्मिथ, कर रहे हैं आप लोग?
सर टेबल नहीं बन रही।
टेबल आप लोग, ये सॉफ्टवेयर कितने लोग हैं, हैंड रेज करें तो कितने लोग इंस्टॉल कर किए हुए हैं, हैंड रेज कीजिए तो सब लोग, और कितने लोग नहीं किए, नहीं कितने लोग किए हैं वो हैंड रेज कीजिए तो। ओके, काफ़ी लोग किए हैं लग रहा है, ठीक है।
सर टेबल प्लॉटिंग में दिक्कत आ रही है।
बट इट्स नॉट वर्किंग, नहीं वर्क करेगा, आप लोग को क्रैक करना होगा। उसको क्रैक करने के लिए अभी जस्ट बताया हम क्या करना है। ये जो मेरा फोल्डर है, देखिए ये मेरा जो EMI का फोल्डर है, सॉफ्टवेयर फोल्डर, उसमें एक फाइल होगा es.dft, ठीक है। इसको कॉपी करना है और C ड्राइव में जाना है। C ड्राइव में जैसे ही जाएंगे ES32 लिखा होगा, इसके अंदर कॉपी पेस्ट कर दीजिए, रिप्लेस कर दीजिए, आपका फिर क्रैक हो जाएगा। और फिर यहाँ से जो एप्लीकेशन फाइल है ये आप चला सकते हैं, ठीक है। प्रणव, अंडरस्टूड और नॉट? स्टिल नॉट वर्किंग। सो एक काम कीजिए, आप लोग जो लोग जिनका वर्क कर गया है वो कृपया प्रणव को समझाएं कि कैसे वो करना है, या प्रणव आप कोऑर्डिनेट कीजिए। इतने लोग जितने हाथ उठाए हैं ना, उनमें अगर कोई एक फ्रेंड है आपके तो उनसे आप पूछिए कि कैसे उन्होंने किया। ओके, बहुत लोगों ने नहीं किया। सो आई वांट माय नेक्स्ट सबमिशन टू बी इन द फॉर्म ऑफ ईएस। ईएस का मुझे फाइल चाहिए बना हुआ, टेबुलेटेड, और उसका प्लॉट, ठीक है, उस फॉर्म में चाहिए। तो ये ईएस सॉफ्टवेयर आप लोग इंस्टॉल कर ही लीजिए। सो जितने लोग हाथ उठाए हैं उनके कोई फ्रेंड होंगे तो आप प्लीज़ हेल्प कीजिए लोगों को, कैसे आपने इंस्टॉल किया। ओके, यू डिड इट बट नॉट वर्किंग। तो एक काम कीजिए, जिनका वर्क नहीं कर रहा है वो कोई और सॉफ्टवेयर है आप लोग के पास, मैथमेटिकल कंप्यूटिंग सॉफ्टवेयर अदर देन ईएस, लाइक मैटलैब, साइलैब। साइलैब भी फ्री है, उसमें ट्राई कीजिए। ओके, आप लोग वापस री इंस्टॉल करके देखिए और फिर बताइए कि क्या प्रॉब्लम आ रहा है। अगर फिर भी प्रॉब्लम आ रहा है तो हम एक ट्यूटोरियल दे देंगे कि क्या करना है। जी, सबसे पहले क्या करना है आपको, फिर से मैं बता रहा हूँ।
Yes, sir, it is working now.
इट्स वर्किंग, थैंक यू। सो पहले सेटअप इंस्टॉल कर लेना आपको, यहाँ पे एक सेटअप फाइल है, इसे इंस्टॉल कर लेना। अभी इंस्टॉल होगा नहीं। उसके बाद ये वाली फाइल जो है es.dft, इसको कॉपी करके सी फोल्डर में जाना है हमें। सी फोल्डर में es32 में पेस्ट कर देना, दैट्स इट। उसके बाद ये एप्लीकेशन फाइल है, यहाँ से आप बार बार आप रन कर सकते हैं। थैंक यू। It seems she has done it, so probably others can also do this. And I want submission in the form of ES, और ES के प्लॉट्स के इमेज डाल के आप लोग वर्ड फाइल जैसे बना रहे हैं उसमें चिपकाना है आपको, ठीक है। और ये दो केसेस, दोनों केस के लिए आप लोग ट्राई करेंगे, जितना हो सकता है कीजिए। नहीं होगा दैट्स फाइन, एटलीस्ट कॉन्सेप्ट वाइज मैंने आपको आज के लेक्चर में हीट इंजन और रेफ्रिजरेटर कैसे काम करता है, या फिर एसी आपका कैसे काम करता है, मैंने आज समझा दिया है, ठीक है, इन सम बेसिक सेंस, ठीक है। सो दैट्स इट फ्रॉम माय साइड। सो दैट दिस कंक्लूड्स दिस सेशन। बिफोर दैट आई विल टेक अटेंडेंस। Okay, I have taken attendance. If any questions so far? If no questions, then we may leave this meeting. Thank you. ठीक है, हम रख रहे हैं।
Thank you, sir.
थैंक यू।
Thank you,
Thank
sir.
you, sir.